homework solution number 4 on question 1. It's energy of point charge distribution. It says for part A, imagine a small square side A with 4 point charges positive Q, 1 on each corner. Calculate the total stored energy of this system, i.e. the amount of work required to assemble it. So here we have a square with 4 positive Q charges on each corner, and they're a distance A away from each other. So work is defined by the function 1 over 4 pi epsilon naught times the first charge times the second charge divided by script r, which is the space in between them. So for work of bringing in 1 point charge, it's going to be 1 over 4 pi epsilon naught times Q times, since there is no other point charge, it's just going to be 0, so this entire thing is 0. For the second one, it's going to be 1 over 4 pi epsilon naught times Q2 times Q1 over script r from charge 1 to 2. Then for work 3, it's going to be something very similar. It's going to be 1 over 4 pi epsilon naught times Q3 times Q2 over script r from 2 to 3 plus Q1 over script r from 1 to 3. Then finally, for the last one, work of bringing in the 4th point charge, 1 over 4 pi epsilon naught times Q4 times Q3 over script r 3, 4 plus Q2 over script r 2, 4 plus Q1 over script r 1, 4. So the total stored energy is all of these things added together. So total work equals work 1 plus work 2 plus work 3 plus work 4. And it's, if we label these 1, 2, 3, 4, or actually, let's see here. 1, 2, 3, 4. It's important to note that script r12 equals script r13 equals script r34 equals script r24, which is all just equal to A. And then script r23 equals script r14, which is all just equal to root 2A from the Pythagorean theorem. So, knowing that, we can add all of these up and just end up, after some reducing, one over 4 pi epsilon naught times 1 over A times Q1 Q2 plus Q2 Q3 over root 2 plus Q1 Q3 plus Q3 Q4 plus Q2 Q4 plus Q1 Q4 over root 2. And since Q1 equals Q2 equals Q3 equals Q4, and they all just equal, positive q. This simplifies even more to 1 over 4 pi epsilon naught times 1 over a times 4q squared plus 2q squared over root 2. So we can just, if we want, rewrite it as 1 over 4 pi epsilon naught a, and bring out a q squared on the top, multiply that by 4 plus the square root of 2. So that's our answer to part A. Then part B says then calculate how much work it takes to neutralize these charges by bringing in one more point charge, negative 4q, from far away and placing it right at the center of this square. So basically for this, we can just write for the 5th point charge, which is something different, it's going to be 1 over 4 pi epsilon naught q5, where q5 equals negative 4q times q1 over script r 1,5 plus q2 over script r 2,5 plus q3 over script r 3,5 plus q4 over script r 4,5. And script r 1,5 equals script r 2,5 equals script r 3,5 equals script r 4,5, which all equal root 2 over 2a, because it's just this distance here from the center of the square to one of the edge point charges, one of the corner point charges. So plugging in these values, making these substitutions, 1 over 4 pi epsilon naught times negative 4q times q over root 2 over 2a, and there's 4 of them, so it's just going to be times 4. Okay, simplifying that, cancel out that 4, and you end up with bringing this up there. It completely simplifies into negative 8q squared over root 2 pi epsilon naught a. So there's the answer to part B, and here's the answer to part A.